Hi guys, so welcome back to my channel. This is Mechanical Engineering Review and Calculator Techniques. Let's proceed to our next problem set. This is problem set number 3, the applications of algebra. So we have 6 applications of algebra in solving word problems. So we have digit, age, work, mixture, clock, and rate problems. So first up, let's proceed to the digit problem. The first step is to represent each number by a variable. So this is very important. So we need to represent each number by a variable. Then second, we should interpret you should interpret the conditions in the problem into a mathematical equation. So if you have two digits that are required to be solved, you should have two equations. So you have two equations and two unknowns. So you have three variables, you should have three equations for that specific problem. For example, we have here the denominator of a certain fraction is 4 more than twice the numerator. If 9 is added to both terms, the resulting fraction is 4/5. Find the original fraction. We have, so the fraction, let's say f as the fraction, that is equal to the numerator over the denominator. So let us interpret the first statement. So the denominator of a certain fraction is 4 more than twice the numerator. So let's say that d is your denominator. That's the denominator of a certain fraction is 4. You have 4 is equals, you have 4 more than, so that is plus twice the numerator. So we have our first equation. So for the second statement, it says that if 9 is added to both terms, if you have this fraction of n over d, if 9 is added to both terms, you have n plus 9 all over d plus 9, the resulting fraction is 4/5. That is equal to 4/5. So you have two equations and two unknowns, so we can solve for n and d. Let's say from the second equation you have n plus 9 equals 4/5 times you have d plus 9. So you can substitute here the first equation. So you have d is equal to 4 plus 2n. So n plus 9 equals, so you have 4/5 d, that is 4 plus 2n you have plus 9. You have n plus 9 is equal to 4/5 times the quantity 2n plus, you have here 9 plus 4, that is 13. So n plus 9, you can multiply both sides by 5. You have 5 times n plus 9 is equal to 4 times 2n plus 13. You have 5n plus, you have 45 equals, you have 8n plus, you have 4 times 13. You have 8n minus This 5n is equal to, you have 45 minus 4 times 13. So you have 3n is equal to 45 minus 4 times 13. You have 45 minus 4 times 13. So that is negative 7. So you have divided by 3. So we have n as negative 7 thirds. So from the first equation, we can substitute the value of n. So we have d equals, so we have 4 plus 2 times n. So we have negative 7 over 3. You have d equals, so you have 4 minus, we have 14 over 3. We have d equals, we have 12 minus 14 all over 3. So that is negative 2/3. So the fraction is, you have n over d. So you have n that is negative 7/3 all over. So you have the denominator negative 2/3. We have cancel 3. We have negative over negative, that is positive. So we have the fraction n over d that is equal to, so we have 7 halves. So let's proceed to H problem. So the key points in solving H problems, of course, the first step is to use a variable for each person. So second, you need to draw or create a table. You have corresponding to the past, you have the present, and the future age. So for example, you have a table, you can say that this is your table. You can say this is the present. Let's say this is the past. So for example, we have 5 years ago. Let's say 3 years in the future. So in 3 years, let's say in 3 years in the future, we have here future. We have here the past. So if your present age is X, your age 5 years ago is of course X minus 5. So your age 3 years from now, you have X plus 3. So you need to remember these two steps. You use a variable for each person and draw or create a table corresponding to the past, present, and future ages. So this is very important. So let's apply this in our first problem. So this is actually one of the most confusing age problem that typically comes out on the board examinations. So you have here, Mary is 24 years old. Mary is twice as old as Anne was when Mary was as old as Anne is now. So you have, how old is Anne? So first, you can let X as the age of Mary. So you have the age of Mary. Say the present. You have Y as the age of Anne in the present. So second step is to make a table. So you have here Mary is. So is correspond to present. We have was correspond to the past. So we only have two columns. So we have the present and we have the past. Let's say the present. We have the past. We have the present age of Mary, that is X. So we have the present age of Anne, that is Y. So in here, let's say that Mary is twice as old as Anne was, meaning the present age of Anne so our first condition that Mary is 24 years old, meaning this is the present age of Mary. So we have X that is equal to 24. So this is actually equal to, we have 24. That is the present age of Mary. You have Mary is, Anne was. So Mary is, that is the present age of Mary, is twice the age of Anne before in the past. So we have, if the present age of Mary is 24, so the past age of Anne is half that age. Since Mary's age in the present is 24, so it is twice the age of Anne in the past. We have here 12. So let's say in the second condition we have Mary was as old as Anne is now. So meaning the present age of Anne, so this is Anne is the past age of Mary. So if the present age of Anne is Y, the past age of Mary is Y. So let's say that the interval between this present and past is of course equal. So we have 24 minus the past Y is equal to the interval of Anne's age. So that is Y minus 12. We can say that 24 we have plus 12 equals, we have Y plus Y, or we have 2Y. So you have 2Y equals 36. So you have Y equals, so divide both sides by 2. So we have 18. So Anne's age is 18 in the present. Next problem. So the sum of Rick and Judith's ages is 18. In 3 years, Rick will be twice as old as Judith. What are their ages now? So we're required to find the present age of Rick and Judith. So in the first condition, you have sum of Rick and Judith's age is 18. So let's use a variable. So let us use a variable to represent Rick and Judith's age. Let's say X be the present age of Rick's age. You have Y, that is Judith's age in the present. So you have your table. Here the sum of Rick and Judith's age is 18 in 3 years. So we have in 3 years. So we have the present and the future. So the present age, let's say this row will be Rick. So this is X. And the second row will be Judith, that is Y. So in 3 years, their ages will be, we have X plus 3 for Rick and Y plus 3 for Judith. So let's use the first statement. So the sum of Rick and Judith's ages is 18, meaning you have X plus Y, that is 18. Okay, so we have Rick will be twice as old as Judith in 3 years. So Rick, so that is X plus 3. So in 3 years, you have X plus 3. Rick will be, that is equal, twice as old as Judith. You have twice as old as Judith. So we have here Y plus 3. So this is very important. So you have in 3 years, so you use the future conditions. So you have x plus 3, that is equal to 2y plus 6. So from the first equation, you have x is equal to, you have 18 minus y. You have x, so we can substitute that to our second equation. So you have 18 minus y, you have plus 3 is equal to 2y plus 6. So you have 18 plus 3, that is, you have 21. So you have 21 minus y, that is equal to 2y plus 6. You have 2y plus y, so you can transpose this to the other side. You have 2y plus y, that is equal to, you have 21 minus 6, so that is, you have 15. You have here 2y plus y, that is 3y, so you have 3y equals 15. So you can divide both sides by 3, so you have y equals 5. So Judith's age is 5 years old in the present. So let's use the first equation. You have x plus y equals 18, so you have x plus y equals 18. You have x equals, so you have 18 minus y, so you have x equals 18 minus, so y is equal to 5. So x equals, we have 13. You have y is equal to 5 and x is equal to 13. So you have letter B. So let's proceed to our next application. This is work problem. So we have the key points in solving a work problem. So the principle of work problem is about the rate of doing the work and the time it requires to complete a job. For example, you have this, so this box or this rectangle corresponds to a one complete job. So for example, you can do a certain job in 4 hours. So in 1 hour, you have this portion done for the job. So you have the rate of doing, so have one job per 4 hours. So in order to complete the job, you need to multiply this rate by your time of doing the work to complete the job. So let's say if you have 4 hours to complete this job, so you have one job per 4 hours, so you multiply that by 4 hours, so you have one complete job. So in other words, so the principle of work problem is your rate of doing the work times the number of hours or days or any unit of time it requires you to complete the job. Let's say time t is equal to a one complete job. So this is the principle of work problem. Let's say for example, a certain person can do a certain job in A hours, another can do the job in B hours. So the rate of that person is 1 over A. So if these two person did the job together, so let's say they did the job in X hours, you have multiplied that to the time, so that is X, let's say X times X. Then they did the job together, so the rate of person B is 1 over B. So they did the job in X hours, so you have times X. So that completes the job. So you have this formula, 1 over A plus 1 over B equals 1 over X. So A corresponds to the number of hours it takes for the person A to complete the job, and the B corresponds to the number of hours it takes for the person B to complete the job, in X corresponds to the number of hours they can do the job together. So this is the principle of work problem. So let's apply this. So a pump can pump out water from a tank in 10 hours. Another pump can pump out the tank in 19 hours. How long will it take both pumps to pump out the water in the tank? We have the rate for pump 1, let's say 10 hours. We have one job. So the rate for pump 1, that is one job per 10 hours. For pump 2, you have one job per 19 hours. So if they work together for, let's say, X hours, this is the number of hours they work together. So they pump out together. You multiply this rate to the time they pump out together, and you add it because they are both doing the job together. That must be equal to a one complete job. For example, you have 1/10, that is rate of pump 1, times the number of hours they work together, plus the rate of pump 2, you have 1/19, times the rate the time they work together, that is equal to a one complete job. So we apply the principle that the rate times time of doing work must be equal to a one complete job. So we have 1/10 plus 1/19, that is 1/x. So we divide both sides by x. We have x equals, we can simplify this, multiply both sides by x. So we have 1/1/10 plus 1/19. So you have x as, so you have 1/1/10 plus 1/19. So that is equal to 6.55 hours. We have 6. You have letter D. So a tank is filled with an intake pipe in 3 hours and emptied by an outlet pipe in 4 hours. If both pipes are opened, how long will it take to fill the empty tank? We have here the intake pipe is actually doing work to fill the empty tank, but the outlet pipe is doing a negative work because it pumps out from the tank. So if you have a rate for the intake pipe that is 1/3, we have outlet pipe, so this is a minus, so this is a negative work. So this is minus 1/4, that is equal to, we have 1/x. So let's apply that formula. So minus because the other one is an outlet pipe, so it actually lessens the job done by the intake pipe. We have x is equal to, you have 1/1/3 minus 1/4. So you have x equals, so 1 all over 1/3 minus 1/4. So you have 12 hours. Here another problem. So we have a farmer can plow the field in 7.5 days. After working for 3 days, his son joins him. Together they plow the field 3 more days. How many days will it require for the son to plow the field alone? So we have, so let x be the number of hours the son can plow alone. So we have a farmer can plow the field in 7.5 days. After working for 3 days, we have the rate of the farmer is 7.5 days. So we have 1/, You have 7.5, that is his rate, times time. So he actually worked for 3 days. So you have 3 times 3. So after working for 3 days, his son joins him. So you have plus. And together, they plow the field 3 more days. So including the father, the farmer, they plowed together, and his son. So the rate of the farmer is 1 over 7.5 hours times. So they work together again for 3 more days. So times 3. Plus, his son joins him together. So 1 over. So x is the number of hours the son can plow alone. So that is 1 over x times 3. So that is a 1 complete job. So if you can examine this, so this is the part wherein the father worked alone for 3 days. So you have his rate 1 complete job per 7.5 days. So multiplied by the rate, you can find the fraction done by the father. The fraction of the job done by the father. So you have 1 over 7.5 hours times 3 days. So plus, you have here, this portion corresponds to the, so they work together. So the father worked for 3 days, and of course the son worked for 3 days. So we had an unknown here. We do not know the number of hours the son can plow alone. So we don't have the rate of the son. So we can find that here. So we have 3 over 7.5 plus, you have 3 over 7.5 plus 3 over x equals, so we have 1. We have 3 over x, that is, so 1 minus, you have 3 plus 3, that is 6. So 6 over 7.5. We have x equals, so multiply both sides by x and divide by 1 minus 6 over 7.5. We have 3 all over 1 minus 6 divided by 7.5. So x equals, so 3 all over 1 minus 6 over 7.5. So we have 15 days. So the son can do the job alone in 15 days. So let's proceed to our next application. So this is the mixture problem. We're going to draw each concentrations. So the second, so if of course if you are mixing material, of course you add the concentration. If you are removing, so you have to subtract the concentration. So in key points in solving mixture problem, the second step is very important. You need to have a mass balance, or the other one is you have to balance the volume. So let's apply this principle. So a 10 liters of 25% salt solution and 14 liters of 30% salt solution are poured into a drum originally containing 35 liters of 15% salt solution. So what is the percent concentration of salt in the mixture? So let's say let X be the percent concentration in the mixture. You have 10 liters, so you need to draw. So the first step is to draw the concentration. So you have, let's say, so this is the 10 liters, so this is 10 liters. This is 25% salt, and so you have plus, we have 14 liters. So this is 30% salt are poured into a drum, meaning so they added it to a 35 liters of 15% salt solution. You have plus, let's say that is 35 liters with 15% salt solution. So the resulting, so that is, we do not know that is X percent, but the total concentration of this, or the total volume is, of course, 10 liters plus 14 liters plus 35 liters. So you have two volume balance. So you have 10 liters plus 14 liters plus 35 liters. So that is the resulting volume. So you apply the first step, draw the concentrations, and of course, you have a volume balance if the volume is given. So meaning this is a 25% by volume. So let's solve this. So you have 10 liters times, you have 25%, so that is 0.25. You have plus 14 times, you have 0.30. We have plus, you have 35 liters times 15%, that is 0.15. So that's equal to, we have 10 liters, so plus 14, you have 10 liters plus 14 plus 35 times the concentration X. You have X equals, you have 10 times 0.25 plus 14 times 0.3 plus 35 times 0.15 all over, we have 10 plus 14 plus 35. So let's solve for X. You have 10, you have 10 times 0.25, so plus 14 times 0.3 plus, you have 35 times 0.15 all over, we have the total volume, that is 10 liters plus 14 liters plus 35 liters. So that is equal to, we have 20 point, you have 0.2025. You have 0.2025. So in order to get the number of percent, need to multiply this by 100. So let's say that X is equal to 20.25%. The next problem, how much water must be evaporated from a 15 kilogram solution which has 5% salt to make a solution of 12% salt? So let's say that X will be the number of kilograms or the mass of water that must be evaporated. So let's have the diagram. So we have a 15 kilogram salt solution, that is 5% salt. So we have, this is 15 kilograms, so this is 5% salt, and this is of course 95% water. So how much water must be evaporated? This means that we need to subtract water from a 15 kilogram salt solution. So this is minus. So But that mass is not given. So that is what we are finding here. That's X. So this is 100% water and 0% salt. So that must be equal to, so a concentration of 12% salt, and of course this is 88% water. This is salt. And we have here, we can have a mass balance. So if we subtract X kilograms of mass here for 15, so we have the resulting mass to be 15 minus, so X. So this is our mass balance. You can apply the principle. So we have 15. So we can either choose to have a salt analysis or water, but since this we are required to find the mass of water, so our analysis will focus on this concentration of water. We have 15 times, we have 95% water, so we have 0.95 minus, so we have X times, so you have 100% is equal to 15 minus X times, you have 0.88. We have 15 times 0.95 minus X, that is equal to, you have 15 times 0.88 minus 0.88x. We can say that negative 0.88x plus x is equal to, we have 15 times 0.95 minus 15 times 0.88. We have negative 0.88 x plus x, that is, we have 0.12x. So 15 times 0.95 minus 15 times 0.88. So we say x is, so we divide both sides by 0.12. You have 15 times 0.95, you have minus 15 times 0.88 all over, so you have 0.12. So that is 8.75 kilograms. So you need to remove concentration of 8.75 kilograms. That is 100% water. So let's proceed to the next application, the clock problem. So the key points in solving clock problem. So if this is the clock, we have 12, we have 1, 2, we have 3, 4, 5. So you have the shorter hand, that is the hour hand, and the longer hand, that is the minute hand. So if y is the hour hand and x is the minute hand, let's say y over x. So the movement of the hour hand is 5 intervals. So you have here 5, so there's 1, 2, 3, 4, 5. That is 5 intervals, so you have 5. But the movement of the minute hand is, you have 60 intervals. So if the hour hand moves, or I mean if the minute hand moves for 60 intervals, so there's 60 minutes, the hour hand will just move for, you have 5 intervals. With the movement of hours hand in term of the minute hand, you have 5 over 60 times x, or you have x over 12. So for every movement of the minute hand x, the hour hand will move x over 12. So I have derived the formula in solving a clock problem. So this is the easiest way to solve a clock problem. So let's try this. So let's say for a given time interval, let's say here, so this is the hour hand. Let's say that this is the minute hand. So in this example, so the minute hand will travel for, you have x. So this is x. So the minute hand travel for x number of minutes. But the hour hand in the other hand, so this will just move for x over 12. So the opposite of 2 is, you have 8. So if this is proportional, you have this angle is equal to this angle. This movement is also equal to x over 12. So if this opposite side, let's say this is y hour, so let's represent this as a variable. So this 8 corresponds to, let's say, y hours. So the number of minutes from this reference point, 0 minutes, from this point is, we have 5 minutes times y. So this is the interval for a number of hours. You have there, so x is equal to, we have this x, that is just equal to x over 12 plus, you have, or how many interval is this, y hours, times, of course this is 5 minute spaces. So this is our general formula. We have x is equal to x over 12 plus 5y. You can say that you have here x times, you have 1 minus 112, that is equal to 5y. By this, you can simplify this with x is equal to, you have 60 over 11 y. So meaning, we have this general formula. You have x is equal to 60 over 11 times y. So there are conditions in using this formula. So I've formulated this condition. So if the hour hand, so the first condition is, if the hour and minute hand are together, you have together, so y corresponds to the given hour. For example, how many hours after 2 o'clock will the hands of the clock be together? So you need to multiply that by 2. If after 3 hours, you have to multiply that by 3. So y corresponds to the given hour. For number 2, the condition is, so the hour and minutes are opposite to each other. If this is opposite, y is equal to the opposite the given hour. So if you have 2 o'clock, so how many minutes after 2 o'clock will the hands of the clock be opposite to each other? So if you have 2, you need to count 6 intervals from 2. So you have 2, you have 3, 4, 5, 6, 7, 8. So 8 is the opposite of 2. You have for third condition, the hour and minute forms a right angle. So your y is equal to, so you have for the first time, so the hour and the minute hand will form a right angle twice. So for the first time, you will count 3-hour interval from that given hour. So we have to count 3 hours backwards from the given time. So for the second time, so we need to count 3 hours forward from the given time. So that is our approach in solving a clock problem. So it's very easy as long as you know this formula. For the first problem, how many minutes after 2 o'clock will the hands of the clock extend in opposite direction for the first time? It will extend opposite. So this is your hour hand. So let's apply the formula. So let's say that x per minute, so that 60 over 11 times y. So this is opposite. So the opposite of 2 is, so you have 8. So y is equal to 8. So 60 over 11 times 8. You have x equals, you have 60 times 8 divided by 11. We have 43.63 minutes after 2 o'clock. So that is letter D. For the next problem, in how many minutes after 7 o'clock will the hands of the clock forms a right angle? So it will form a right angle twice. For example, you have here, so the formula we have x is equal to 60 over 11 times y. So for the first time, we have 60 over 11 times, so y is, so we need to count 3-hour interval backwards. So you have 7, you have 6, 5, 4. So that is times 4. So for the second time, so we need to count 3-hour interval forward. So we have 7, 8, 9, 10. So that is 10 times 10. So you have 60 over 11 times 10. So that's equal to, you have 60 divided by 11. You have times 4. So that is 21.81. So for the second time, you have 60 divided by 11. We have times 10. We have 54.54. So that is letter A. So I apologize for this. So this is supposed to be 21.81. So this is 21.81. So this is 54.54. So this should be 21.81. So in how many minutes after 7 o'clock will the hands of the clock be together? So in this case, you have x, 60 over 11 times, so you have y. So in this case, if this is together, so you need to multiply this 60 over 11 to the given hour. So that is 7 times 7. So you have x equals You have 38.18. The next application of algebra is rate problem. So here are the key points in solving rate problems. So you have the velocity that is equal to the change of distance. You have distance over time. So we must always consider velocity as a vector quantity, so it has direction. So we take note that we have a velocity is equal to distance over time. So this is our concept. For the first problem, a jogger starts a course at a steady state of 9 kph. 6 minutes later, a second jogger starts the same course at 11 kph. How long will it take the second jogger to catch the first? So in order for the second jogger to catch the first, they should have equal distance. So we can say that the distance traveled by the first jogger is equal to the distance traveled by the second jogger. So you have the velocity, that is distance over time. Therefore, we have the distance that is equal to velocity times time. So let's say that we are finding the time it requires for the second jogger to catch the first. We can say that T sub 2 is the time required for the second jogger to catch the first. So here d sub 1 is equal to velocity times time. So v1 times t1 is equal to v2 times t2. So let's take note that the first jogger already jogged for 6 minutes. So therefore the total time for jogger 1, that is t sub 1, is equal to, we have 6 minutes. We have 6 minutes plus the time it takes for the second jogger. So this is the total time required for the first jogger. We have v sub 1. We have t sub 1, that is 6 times. 6 plus t sub 2. So is equal to v sub 2 times t sub 2. So v sub 1, the rate of the first jogger is 9 kilometers per hour. So you have 9. So times 6 plus t sub 2 is equal to v sub 2. The rate of the second jogger is 11 kilometers per hour. So we have 11 times t sub 2. So there's no need to convert the units because it will only cancel out to both sides. We can say that 9 times 6 equals, you have 54 plus you have 9 t sub 2. It's equal to 11 t sub 2. So you have 11 t sub 2 minus 9 t sub 2 is equal to 54. So we have 2 times t sub 2 is equal to 54. And say that t sub 2, we divide both sides by 2, that is, we have 27. So the time it requires for the second jogger is 27 minutes. So you have this second problem. So a boat can travel downstream in 2/3 of the time as it goes going upstream. So if the velocity of the river's current is 10 kilometers per hour, what is the velocity of the boat in still water? So we can have this diagram. Let's say that this is the stream. So let's say that the velocity of the stream is going to the right. So let's have the boat. So the boat is traveling with the stream. So the boat is traveling downstream. So going back, so the boat will be traveling against the stream. So the boat is traveling upstream. We can say that the velocity of the boat downstream, so this downstream, is equal to the velocity of the boat plus the velocity of the stream. So going back, so we have the velocity upstream is equal to the velocity of the boat minus the velocity of the stream. So we can see that the velocity upstream must be less than the velocity downstream, since the water is opposing the boat when it goes upstream. Let's say here that the boat can travel downstream in 2/3 of the time as it goes going upstream. You can say that the time downstream is equal to the 2/3 of the time it goes upstream. So that is our first condition. But you can say that the velocity, that is distance over time, so you have the time that is distance over velocity. So you can say that for the time downstream, that is the distance, so this distance all over, you have the velocity downstream is equal to, you have 2/3 times time upstream, that is distance over the velocity upstream. You can take note that the distance going and going back is equal. So we can cancel this distance. So we have 1 over VD is equal to 2/3 times 1 over velocity upstream. We can say that the velocity upstream is equal to 2/3 the velocity downstream. You can substitute this. You have VB plus V sub S for downstream, the velocity of the boat minus the velocity of the stream upstream. You have V sub U, that is VB, minus V sub S is equal to 2/3 times you have VD. You have velocity of the boat plus velocity of the stream. So we have given here, so the reverse current is 10 kph. So this is the velocity of the stream. The velocity of the stream. So you have Vs as 10. So Vb minus 10 is equal to 2/3. So Vb plus 10. And solve for V sub B. You can shift solve this. So we can open our calculator. So that V sub B, we have alpha x. You have minus 10. You have alpha. You have calc. You have 2/3 times you have alpha x plus 10. Again, plus shift calc, shift solve. You have the velocity of the boat is 50 kilometers per hour. For the next problem, so a boatman rows to a place 5 miles with the stream and back in 14 hours, but finds that he can row 15 miles with the stream in the same time as 3 miles against the stream. Find the rate of the stream. We can have this diagram and say that if the boat travels downstream, so it is traveling with the stream, so this is the velocity of the stream and this is the velocity of the boat. You can say that the velocity downstream is equal to the velocity of the boat plus the velocity of the stream, since it is in the same direction. So going back, you have the velocity of the stream, so the velocity of the boat is opposing the current, so you have the velocity of the boat. So this is the velocity upstream, so this is equal to the velocity of the boat minus the velocity of the stream, since it is in the opposite direction. So using the first condition, so a boatman rows to a place 5 miles with the stream and back in 14 hours. It means that the time it takes to travel downstream plus the time it takes to travel upstream, that is going back, is equal to 14 hours. So back and forth, the boatman traveled for 14 hours. We have the velocity, that is distance over time. You have the time, that is distance over velocity. So you have the time downstream, that is the distance downstream all over the velocity downstream plus The distance upstream over the velocity upstream is equal to 14. You have here the distance, the distance is given as 5 miles. So say that the distance, of course, the distance traveled is the same going back and forth. So you have the distance is equal to 5 miles. The distance back and forth, so distance going and going back is equal. So you have the distance is 5 miles. It's given as 5 miles. So you have 5 over v sub d plus 5 over v sub u is equal to 14. So we have our first equation. For the second condition, he finds that he can row 15 miles. So you have 15 miles with the stream, so that is over, with the stream, so that is downstream, is equal to the time it takes 3 miles against the stream. So you have 3 miles against the stream, so that is upstream. So this is the time it takes to travel 15 miles downstream. It says in the problem that is equal to the time it takes to travel 3 miles against the stream. So we have our second equation. So we can say that v sub d is equal to 15 over 3 times v sub u. So we can substitute that in the first equation. So you have 5 over v sub d, so that is 15. You have 15 over 3 v sub u, so you have v sub d, you have 15 over 3, so that is v sub u, plus 5 over v sub u, so that's equal to 14. So we can shift solve for v sub u. You have 5 over, you have 15 alpha x, so that is alpha calc 14. You have shift calc. You have x as 0.42857. So you have v sub u. So you have v sub u is 0.42857. So in order to get v sub d, so you have to multiply that by 15 over 3. You have times 15 over 3. The 0.42857. And for v sub d, so that is 15 over 3. Using the second equation, that is 0.42857. So that is v sub d, that is equal to, you have one. So v sub d is equal to, so v sub d is equal to 2.143. You have these two values. So using this, so you have the downstream velocity, so you have 2.143. So you have 2.143, so that is downstream. So we have velocity of the boat plus velocity of the stream. So going upstream, so we have 0.42857. So 0.42857, that is equal to v sub b minus v sub s. So this is for downstream, so this is for upstream. So using these two equations, you can find for v sub b and v sub s, but we are only required to find the v sub s, the velocity of the stream. So v sub s equals, so we can use our calculator for these two equations, two unknowns. We have mode equation, so that is mode 5. And for two equations, two unknown, you can use this one. So a sub n corresponds to the coefficient of the first variable. So in this case, that is v sub b. And the b sub n corresponds to the coefficient of second variable. In this case, we have v sub s. So the c sub n, this is the constant. So in this case, you have 2.143 and 0.42857. So you can use that one. So for the coefficient of the first variable, so v sub b, so that is 1. For the second variable, so that is 1. So the constant is 2.143. So for the second equation, you have the coefficient of the first variable, so v sub b, that is 1. For the second variable, that is negative 1. And the constant is 0.42857. Press equals, you can automatically find the value of x. So that is the value for the velocity of the boat v sub b. But you are required to find the velocity of the stream, so the other variable. So that is 0.857. So that is letter A. So that's it, guys. So I hope that you learned from this topic. Continue to support this channel by liking, sharing, and subscribing. See you on my next video.